Hi, welcome back to Building 9, the Space Vehicle Mock-Up Facility. We're back with the RATS Group Research and Technology Studies, and this time we're talking with Steve Rader, who is the data manager for analogs. Analogs are ways that we simulate missions here on the ground, and in this case we're doing again an asteroid simulation, and he is working on a lot of different aspects of that. Why don't you tell us a little bit about what all you do?
Okay. Well, I work a lot with the integration of the systems, making sure that all of these different projects that come together for analogs, that their software can talk, that all of their systems can talk on our networks, and that they will all work with opposite systems like the control centers and our little control workstations we have all around here. And then I make sure that we can get all those systems to work over the delayed comm. So what we actually have here is communications that are 50-second delayed one way. So to the asteroid would be one-way light time, and back would be 50 seconds as well. So for me to have a conversation with you, it would take 50 seconds for you to hear me, and then 50 more seconds for me to hear your response. So a minute and a half for any round trip conversations we have.
Should we demonstrate that for us? Maybe
Might
not,
be kind of boring.
Okay, well tell us a little bit about why we're delaying the communications at all.
Right. Sure, well, like I said, the light time, the time it takes light to travel, which is the time it takes our radio signals to travel, increases as we go out from Earth. And so, for instance, Curiosity is going to be landing here in a few weeks. It's on Mars, and at this point in its orbit, it's about 14 minutes for light to travel all the way out to Mars from the Earth. And so for them, it takes 14 minutes for a command to go to that vehicle, and it takes another 14 minutes for data to come back. And so we're practicing for an asteroid that's not quite that far out, but still significantly far out. The moon is about 4 seconds. And so because we're sending crews, we have an additional dynamic of humans in the loop, and those humans are for the most part used to a conversation with the ground control, mission control. And so we're trying to develop new ways to communicate and to understand how much autonomy they need, what their roles are versus the ground's role, and then when they do have interactions, how do we best do that? So a good example of that would be texting. We actually don't use texting currently very much on space station because we can have those real-time conversations, but we've started in the analogs testing using texting as a way to communicate better because people are really used to that paradigm of using asynchronous messaging, or messages that get there not when you're expecting them, and you read them a little later and then you respond, and how that message flow works and how that works with operations.
And you've done this a few times now with, I guess, maybe Deserats last year and certainly the Nemo mission this year.
Yeah, and then the Resolve payloads as well that we've been doing with landers. So all of these analogs, and they all kind of converge towards answering some of those questions and helping us develop the right tools to deal with these situations.
And it sounds like a small thing, you know, you just wait a few minutes and you get your answer, but I mean, it's a big deal, something we have to figure out before we go to, say, Mars, right?
It is, yeah, absolutely, because it changes depending on what you're doing, how important that thing is, how off-nominal, in other words, if there's a problem, how long it takes something bad to happen. So we call it time to effect. If there's a valve you turn and you start hearing a hissing noise, is that going to affect me in a minute or 5 minutes? And
do you have the 14-minute?
Right, do I have time to actually ask a question and get an answer before that bad thing happens? So you kind of have to think through all of that in terms of what you train crews for, but also the tool set that you provide them. We did some simulations on Nemo where we were using the crews, and we were using 5-minute and 10-minute delays where we had emergencies. And during those emergencies, what we found is if we weren't careful, the ground would acknowledge a message from the crew and say, yeah, we heard that, now do this. By the time the crew got that direction, their situation had changed significantly, and that was actually the wrong direction to give them at that point. And so a better understanding of the context of when somebody says something and why is tools we're working on how to facilitate that, if that makes sense.
Right. So do you feel like we're making good progress and we're going to learn a lot that's going to help us in the future?
Absolutely. We're working on several mitigation techniques, several studies to understand the impacts, and those we're actually starting to meet together with all of the different analogs to really understand that. And then some of that will be used in our testing, our new analog that we'll be doing, ISTAR, which will actually have crew members on the space station using delayed comm back to Earth. in a more operational scenario.
Right. So it just keeps getting more and more realistic.
Right.
All right. Well,
And we use these to try to do that at a low cost.